The first step when you construct an angle bisector is you construct an arc that passes through both sides of the angle. And so you're creating the arc side intersections. So what that looks like is you place your compass tip on the vertex of your angle. You widen your compass as far as you need to. Again, the further out you go, the more likely you're going to be accurate with your construction. So you want it out a decent length or a decent radius. Okay, once you construct your arc side intersections, you're going to place a compass tip on one of those arc side intersections. And you're going to construct an arc in the interior of your original angle. Okay, so there's no reason to adjust your compass setting. You can just leave it exactly as it is. Okay. Construct an arc in the interior of your angle. You don't have to extend it beyond the interior because an angle bisector has to fall in the interior of an angle. And then you're going to repeat this step from the other arc side intersection. So once again, without changing the compass setting, place the compass tip on the other arc side intersection, construct an arc in the interior of that angle, and you should find an arc-arc intersection. The final step is to connect this arc-arc intersection to the original angle's vertex, and that will be your angle bisector. Okay, so if you connect from the vertex, pass it through this intersection, you will have bisected this angle. So I'm going to label point D on this angle bisector, just so I can label some relationships. And the relationships that we're able to create is angle ABD and angle CBD. Because they're angles, will these be equal or congruent? They're congruent. Any objects, any geometric objects have congruence associated with them. So that means these angles are equal in all respects. So if you want to talk about their angle measures, you would use the small m, the measure of angle ABD, and the measure of angle CBD. Now you can talk about the equality of their measurements or magnitudes. But the physical objects themselves, the angles themselves, are congruent to each other. Keep in mind, anytime you're working with short sides of angles especially, you can always extend the side to make it easier to use your construction tools. So don't be afraid to extend side AD. So if I was constructing the angle bisector here, I would create two arc side intersections, create an arc that passes through both sides of this angle. Without changing the compass setting, construct an arc from one arc side intersection in the interior of the angle, duplicate that from the other intersection, and now I can connect that back to my original vertex. Oops. And that will form angle bisector. Okay, now, a couple things, or one more thing to point out here. Okay. In this step where you construct your arcs from the arc side intersection, and what happens if your compass gets adjusted so that it's not the same length? You think that's going to affect where the angle bisector is drawn? It's not. So if I look at this, if I construct from here, as long as we use the exact same setting, you're still going to have intersection on that angle bisector. And now the advantage to keeping it the same, one, it's just one less thing, one less adjustment to make. There's no reason to add an extra step. And two, if you look at the steps that we used for this, if we were to connect all the points that are that setting, that compass setting away from each other. So here, these two segments are that same length. If we then connect from here to our intersection, so all four of these segments were drawn with the same compass measure. So what kind of a figure did I create right there? It's a rhombus. And so when we get into the later, I'll do it in green so it's easier to see. When we do construct a rhombus later in the year, this is all we're doing. Basically, we're just doing the construction for an angle bisector.